Hello, everyone, and welcome to the Constraints Collective podcast. And today we're joined by Kane, Middleton and Jack Bale from La Trobe University. Hello, gents. How you doing?
Yeah, good, thanks.
Martin, thanks for having us.
No, great. So Jack is returning from a previous episode. So welcome back, Jack. And yeah, looking forward to chatting to you as well, Kane, just about the work you've been doing, which is really exciting. That we'll get into in a sec. Keith, how are you? I know you're not happy with the weather or incoming weather.
Yeah, well, I'm delighted that having the two guests on, Kane and Jack. We've been talking to you guys for a while, since before the new year, the turn of the new year, about coming on, and so this is very exciting, I think. So I'm going to talk about shooting performance and how we can navigate it and how we can design practice tasks for it. So I'm looking forward to it. But actually, I'm fine, Martin. I'm well as well,
Good,
thank
good. Yeah, you're looking in fine fettle, so good. So Kane, would you mind just giving us an introduction to yourself, some of the work you're doing, and then specifically focused on the shooting? Is that okay? And then we'll go to Jack.
Yeah, that's fine. Yeah, I've been at La Trobe this is my 10th year. I did my PhD in cricket fast bowling at the University of Western Australia over in Perth. A lot of my background in research has been in cricket and sports biomechanics. After my PhD and a short postdoc at UWA, I went over to the University of Wollongong in New South Wales, but I was embedded with the Defence Science Technology Group based in Melbourne. And in that role, I was helping develop new fitness standards for the Australian Defence Force. From that position, I came into La Trobe, continued my sport research background, but then I developed a lasting interest in defence research. It was mainly physical performance, but I had a colleague who is now a PhD student who should be submitting in the next few months, Gemma Coleman, who was in charge of or has expertise in ergonomics, working at DST, and she was doing her PhD on shooting performance, more marksmanship shooting, whereas today I think we're going to talk more about close quarter combat shooting. And she developed a PhD. I helped her as a supervisor over the last few years. As I said, she'll be submitting soon. And then from there, over the last few years, we've had a grant to look more closely at close quarter combat shooting, developing or looking at a sensor that can be used. And we'll get into that, I think, throughout the chat today. And then also having Jack on board as well, which has been good. So my expertise is coming from the biomechanics perspective, traditionally very deterministic, but my eyes have been opened over the last few years into more of an ecological dynamics perspective.
Brilliant. Thanks, Kane. Jack, I know it wasn't too long ago you came on the show. I suppose, yeah, reintroduction, and then just maybe a bit of insight about what you've been doing with Kane. That would be great.
Yeah, sure. So I'm doing my PhD with Kane at the moment. So I'm looking at task ambiguity in combat shooting and how different constraints affect combat shooting performance and behavior. And my prior background to that is all in sport shooting, so in ISSF rifle shooting. So pretty much anything with a gun, I seem to be trying to do research in it. But yeah, that's what I'm doing at the moment.
Brilliant. So, really curious. So, just because I've spent time in the military myself a long time ago, but I'm just really curious about maybe what you've been tasked with, what you're trying to do, what you're trying to change possibly in terms of, I know you mentioned close quarter combat. Is it around training design? What sort of issues maybe you're trying to solve? So, yeah, I don't know if we could delve into that a little bit. It'd be really interesting actually to hear about that.
Yeah, I might start and just put the project into context, and then I can hand it over to Jack to really go through what he's doing for his PhD, which is very relevant, obviously, to the Constraints Collective. as I mentioned, Gemma previously, who was at DST, she was in charge of looking at she was in charge of a project which was looking to replace small arms within the Australian Army. So they currently use a bullpup style rifle, and they were looking at potentially changing that to a different style. So her PhD was based on more of I'll call it more of a pure biomechanical analysis, ergonomics engineering type analysis of seeing how changing weapon system configuration influences performance. It's a really interesting spectrum of defense forces, particularly in Australia, would tend to look at performance of a new weapon system by just having someone go shoot a few times, ask them some questions, have a look at some accuracy, precision data, maybe 1, maybe 2, 3 shots, and that's it. There was no account for the human in the system or human in the loop. So her PhD included the human in the loop, looked at what changing a weapon system configuration does, not just to accuracy, precision. How does stability change at the rifle? How do kinematics change? And also muscle activation. So she was going from taking defense from very engineering focused, introducing human in the loop, and then it kind of expanded then to start looking at maybe some perception action coupling as well. So the cognitive aspects or perceptual aspects. So our project was really based on trying to, initially looking at a wearable, a sensor, a weapon-mounted sensor that could give feedback to shooters. And the big part of that is that shooting in a range costs a lot of money for ammunition. It's a lot of resource time to hire a range, hire out weapons, sign them out. So they looked at a sensor called the Mantis X, which is off-the-shelf sensor, and they're based in the US. And we were tasked with trying to validate that sensor, see whether it's accurate or valid in terms of what kind of feedback it's giving, the movements that it's saying it's doing, as well as seeing whether it's effective in a training environment. The other aspect of that, so the initial aspect was about the Mantis X sensor. The additional aspect was the perception action coupling. So can we start to integrate more information about how soldiers shoot, how they interact with the environment, how does that influence performance? And then those two kind of areas in terms of our project started to merge in terms of, okay, so how can we actually provide some information to defense about improving training? So it was kind of came from two aspects from the project. And then I think what really helped us drive the perception action coupling perspective of the project is having Jack on board, who had a really good experience in his previous degrees in both movement variability as well as shooting. So it was a really good mix of expertise that he brought along to really drive that aspect of the project. So maybe Jack can explain exactly what he's doing in his PhD that is related to that.
Yeah, great overview, Kane. Thanks.
Yeah, thanks for that, Kane. Just before you get into your work, Jack, Kane, would it be right to say that before this project work and before your interventions at La Trobe, that typically Defence Force research was focused on things like, quite as you mentioned before, the engineering aspects of weaponry and equipment, the impact on physiology, for example, regulating temperature and that sort of thing, carrying loads, ergonomic aspects, biomechanical aspects, and moving things into the sort of performance, the skill acquisition, the training side is quite an advance. Would that be fair to say?
Absolutely. It's kind of gone in coming waves, I guess, in terms of what the priorities are in the Australian Defence Force in terms of research, particularly human performance research. Early in the 90s, probably before I started DST, it was all about injury rates, finding out why people are getting injured. The work I did was about those physiological and biomechanical aspects of the job and job task analysis to try and reduce those injuries and selecting the most suitable person for the job. Then it merged into, and it comes in waves due to funding opportunities and what the current government wants and what the chief defense scientist wants at the time. It moved into definitely more injury workload monitoring, and that's probably been the last 10 or so years. So we had some funded research looking at gait variability in a recruit population, but there's other universities who've got funding to look at workload management. There's quite a bit of cognitive work that's happening in Australian defence. And then, so they were kind of centralised type programs that were open to lots of different, open to the complete Australian university sector, really. Whereas this particular project was a select few people were invited to apply because they had previous experience with shooting performance research. And it was really driven by the new weapon systems potentially coming in if they decided to change that. So that was what drove this funding opportunity. What I didn't mention is that although our project started with that, there was a defense strategic review that came out halfway through the project, which completely changed the funding. I guess how funding was being put out into the Australian university sector to do with defence, and that aspect of the project really got put at a low priority. So we changed and shifted to more of that training, and I think that's something where it was really appreciated by the participants who were there. One thing that really struck me was being able to do some eye tracking on them as they were doing their room clearances, and they had never seen that before, and they thought it was absolutely great. So I think there's aspects of trying to introduce technology to people. I think there's a really big opportunity to develop education resources for soldiers to be able to see what a good run through is, where you should be looking, rather than just being told theoretically where you should look and how you should do it. That gaze data, I think, is one of the most valuable pieces of information we got in the project.
Fantastic. Yeah, interesting to trace the historical thing you mentioned before about that some of the early research was focused on the need to identify traits in people where they could be selected for certain tasks, and that's exactly, you can trace that back to the beginning of cognitive psychology, where during World War II, engineers, ergonomists, and psychologists got together on university campuses in the UK and the US particularly to talk about two issues: whether it's better to you can design tests to identify people for certain jobs, like people who've got good attentional skills over time. Will they make good radar operators? And other people who could had good hand-eye coordination, would they become good marksmen and things like that? So it's pretty much identifying the idea of identifying traits in people and selecting them for certain military tasks. And historically, that's been a dominant thing in skill acquisition research. It was very pragmatic in the sort of early 1930s, 40s, and 50s. And from that, then after the Second World War, the psychologists came away saying, engineers, there's a thing called the computer that they're working on, and it takes in information, then the computer transforms it, and then there's an output, and that sounds like human behavior. When we take in information, the brain transforms it, and then there's an output. So it's still that thread that sort of ignited skill acquisition research from a very pragmatic view, not so much about, let's get the theory, let's understand the concepts, but what about how can we select people, or would it be better to train them to do jobs? And eventually there's still obviously the idea that's still there of selecting people, but the training. It's good to see the training elements coming in and how to design better training environments, and particularly mentioning perception and action, as you said.
Yeah, that
What's interesting, so what's interesting about that is I think that's still to come within Australian Defence. When I mentioned about the most appropriate person, it was more about the physical attributes, and the actual way we did that was to remove any skill-based actions. And as I mentioned, it's about kind of things that happen, provide opportunities for defense to really focus on one thing. And a big thing 10-ish years ago when I was doing that was the gender restrictions were removed from combat roles. So there was a opportunity for females to be able to go into roles that they were traditionally not allowed to go into. So that was one part, but then also just from a injury reduction perspective, can we quantify what effort or what physical requirement or demand there is in a particular job and the tasks they do? And can we set tests for people to go against, to pass or fail, to say whether they are fit enough to do that job? So that was purely physical. And why I think it's interesting is because what you're saying about previously in the 50s and 60s, I think is now coming full circle again to be more about skill-based, because more and more time goes by, war is going to probably be in urban environments. There's less requirement to have really high physical fitness and demands to be able to carry load for hours on end. It's going to be mechanized, it's going to be on trucks, there's going to be drones, might get dropped into an urban environment, and there's not much physical requirement in terms of long load carriage. That's just my guess. So higher skilled tests relevant to cognition and decision making are probably going to be more paramount moving forward.
Fascinating. And of course, that leads us to Jack's research. This is where you're ahead of the game at La Trobe on this, because the focus on cognition, perception, action, decision making, as you said, problem solving, and the idea that maybe training designs need to catch up with these projections, which by all accounts looks pretty accurate, actually, the way things are going around the world in some places. So yeah, over to you, Jack.
Yeah, so I guess my research follows on from Gemma's research, and as Kane mentioned, it's more about training design and how one might interact with a gun, I guess. So with that in mind, the idea of the PhD to start with was to look at representative design. So how do we create a representative training environment in combat shooting? And that led us to do a scoping review to try and understand the research at the moment, sort of what constraints are typically included in research and training design, and what constraints are unfortunately mitigated or can't be included. Of course, not all constraints in quite a dangerous environment can be included in training, but it's how do we get around some of these things? And one of the main key areas that is typically mitigated in a wide majority of the research, not everything, like there is research in these areas, but it's limited, or there's quite a few limitations with it, so it's hard to interpret for the actual environment. But it's task ambiguity. A lot of features, for example, the need to identify friend or foe from multiple targets, the need for friend or foe in general, or having information emerge instead of being presented to you before a trial starts. Those are all things that are typically not included in combat shooting research. So trying to understand the effects of these is where we are moving to, and that will be the last paper, or the last two papers in my PhD, to try and understand the effects of these on combat shooting.
Excuse me, Jack. We mentioned this before on the last one, but could maybe, if people didn't listen to that, just this point about task ambiguity, could you just maybe delve into that a little bit more and unpack it?
Yeah, sure. So it has three different components. So what we're trying to say from an ecological point of view, what we're not saying is that information sources themselves are ambiguous. So we're saying that information is unambiguous. So red cannot be green, for example. It's quite a broad example. But what we are saying is when information is woven together, when there are multiple possible affordances in a environment, that's when a task itself can become ambiguous within the greater environment that is embedded, basically. So that has three different components. The affordance landscape. So this is all the possible affordances that someone can attune to. This is made more ambiguous, for example, if there's more different types of targets or more types of targets in the environment, then it's because the choice to shoot a certain target in this case is harder to make if there are more targets to shoot. Which do you do first? Which is the biggest threat to your survivability, for example, in this context? It does also apply to sports as well. So it's not just combat shooting that this applies to. Then there's information uncertainty, which is the close likeness of information. For example, faux targets, so targets that do actually need shooting, dressing as civilians. So they are masking their own intentionality within the environment and trying to copy the information of other information that specifies a different action. Again, trying to increase ambiguity. However, there are features on their person that would highlight them as not a civilian or a friendly target, like metallic objects or implements under clothing, their own actions or facial expressions. There are things there that will highlight them as someone who is not a friendly. So it's being able to attune to this specifying information. So specifying information being the most useful for achieving the task goal. And then it's the third point of task ambiguity, which is, again, quite often mitigated in combat shooting research, which is the emergence of information. So very rarely do we know the exact location of these targets within an environment. So often we know they're in a certain location, but we cannot know for sure where they are, who they are within that environment before entering it. So we have to go searching for this information. We have to navigate through the environment or position ourselves in a way that we can understand what's going on and where the information is presenting itself to us. And usually in combat shooting research, people will have a run through of a course, or they'll know where the target is because it's on a static, quite linear range. And that there has been research in the US to show that unplanned protocols take longer to complete for obvious reason. We got to go find the information itself. But if we don't embed that into training, then we're not going to develop these particular behaviors strongly to become quite unskilled at finding this information, basically.
Yeah, that was good, Jack. Sorry, Martin. Yeah, I was just saying that that's an important point that you make there about from an ecological perspective, information is not ambiguous. In other words, it's either specifying or non-specifying. That's clear. And as you say, specifying information is like the gold standard information that you use to organize your actions, to make your decisions, to perceive what's going on around you. Non-specifying information is what you may use when you're less skilled. And the more skilled you become, your tendency to use specifying information to organize your actions is clear. Task ambiguity, from an ecological perspective, is, funnily enough, the more information that you add into a practice task, the more uncertainty you create, because people have to make decisions about, it's not just, is it specifying or non-specifying, but there's a selection between sources of information to use and affordances to attune to. So as you say, a metallic object in the hand may have the affordance of being, a spoon or a cooking implement, or it may have the affordance of being a weapon. And people have to sort of make decisions based on the information, the type of reflection, and the color and all this sort of stuff. I mean, you know much more about this than I do, but I just wanted to pick up that the two key points you mentioned there, really, about information can't be ambiguous. It's either specifying or not. And secondly, but the conditions of the task can be ambiguous.
Jack, really curious how this is. I don't know if you've done this yet, but how it translates into practice. So when you was talking, I was just thinking a long time ago, and I really like the point Keith made at the beginning. So let's say the old way or the traditional way, it just fits with like a military model. They want efficiency. You come in one end, you're out the other, and you're ready to go into your unit or whatever. It just all aligns to me. And one thing I'm thinking about is because it has got quite strong or very strong historical sort of constraints, I suppose. And the other thing so I'm thinking when you do these run throughs that you were talking about, it's normally live firing. So you'll have two instructors as well. That's another giveaway. Stood next to you because of the safety element, and they'll tap. I'm remembering back. They will tap you on the shoulder when you can actually move forward. And obviously, you're not live firing against live objects. It's normally, well, it is static objects that are very obvious. So it could be a car, a building, like a target, like you know what I mean? And it's very controlled. So there's no searching for well, there might be searching for information, but it's on a very low level. You're not having to distinguish between certain things. And then the opposite of that is when you are doing what you might call battlefield simulation, but it's not live firing. So there's no feedback mechanism. You're just shooting a blank. And it's like, I remember in the past people would be holding the rifle, you know what I mean? You're reducing that level of realism, even though you might be getting barked at to aim properly and all the rest of it. So, the sophistication and these ideas, it's brilliant. It's like music to my ears. But I'm just curious, like, how's that translating into actual practice? Like, how are people changing things based on this information?
Yep, a great question, and one defense has asked already. Like they're quite open to the ideas, but how do they implement them?
Yeah.
So that's obviously quite important for them. And again, it's sort of a spectrum of representativeness, I guess. So, like say, historically, training has been very linear on very static ranges. Because ethically it's safer to do so. Cheaper to set up environments like that as well. And therefore the infrastructure is quite embedded in these static ranges, unfortunately. So that it's hard to obviously implement. And then obviously you've got to make sure someone can understand how to use the gun first. There are some constraints that you can put into practice straight away, like time constraints. We're currently investigating how useful it is, even in static ranges, to put in time constraints. And are pre-prescribed time constraints good, or is making it more context specific better? And that brings me into my sort of second data collection, where we looked at task ambiguity itself. And as you mentioned, you can't live fire against someone else, not your own teammates. So you're quite limited in what you can do. And like you say, traditionally it's been dry firing run throughs or firing blanks. But you have no feedback. There's no, you don't know how well it went. It could have been anything. The scenarios are designed to play out in a certain way. So what we used was training ammunition. So they are firing something. The recoil is much less. The rounds are still flying extremely fast, and they don't tickle, so they do hurt when they hit. So there is, and it has been seen again in the research to cause quite a lot of anxiety in people using simulated training ammunition. So it's good at simulating, again, not to the same level, but certain constraints that you would actually find in actual combat. And we used a small room, so I think it was 10 by 5 meters. So not a big room to recreate a task. And one of the embedded tasks in an overall task game, which is trying to identify a friend or foe target and shoot that foe target. We had eye tracking on, so we couldn't have the foe target shoot back at the participant. Without eye tracking, you could get a foe target to shoot back at the participant, and again, that adds another layer of realism or representativeness, and makes the time constraint relative to the scenario. So, for example, if the doorway is only 2 meters away from someone, they probably won't even aim. They'll just point the gun and shoot. Whereas if it's 7 meters or further away from them, they might actually spend a bit longer to aim to make sure they can hit someone on the first shot. Because again, in the research, it's seen if you can eliminate a threat on the first shot, your chances of surviving an engagement go up dramatically. So, yeah, that's sort of how you would embed it in sort of these new shoot house like facilities, and you would use quite safe training ammunition. Again, once they've learned how to use the operating systems that they're using.
Yeah, I never thought of that. I didn't realise they had training ammunition. Yeah, interesting.
The idea is that the practice task constraints are beginning to simulate the performance environments that they are likely to encounter, as Kane mentioned before. You know, the nature of military conflicts may be changing. And Jack, you mentioned the friend or foe discrimination task in the training environment. That's surely going to become more and more important given the nature of military conflicts around the world in some places.
Absolutely. Yeah, absolutely. I mean, it's been a while since we've seen a conflict where both sides are wearing quite distinct uniforms and also lining up without civilians on the battlefield. So, yeah, the need for friend or foe discrimination will only get greater with greater urbanization. The easiest thing for a foe target to do is hide in a crowd of civilians. Right? It makes them extremely difficult to identify before they actually become a threat. Compared to just standing in the open, very obvious, like how training has typically been. Yeah.
I love the point about anxiety. I just remember even the fact of loading a magazine with live ammunition would change the whole scenario, and you know, going onto a range. Whereas if it was like simulation run-throughs with firing blanks, it was just totally different, very relaxed. People were not messing around, but it was quite a relaxed environment. But yeah, the minute you'd start putting live rounds in a magazine, it just changed the whole vibe. Really great point that is, yeah.
Yeah, there's a consequence for action, right? So if you make a mistake, the mistake is quite apparent. And with training ammunition, again, the mistake is quite apparent to yourself if you're the one hit with it. It does provide some discomfort and to obviously elicit some form of anxiety response to simulate some of the conditions that you would actually find.
Yeah, great point. And Jack, are you actually doing this? Like, are you working alongside like military personnel at the minute, like to redesign these practice environments?
We worked with the battalion in Brisbane to design my last day collection. At the moment, we're not specifically helping them pass that. We're very open to moving forward, but yeah, we worked with them to design this task. To ask them what do they currently do in training. We basically designed a task where a shooter stands close to the center of the room, and they've got 3 doorways that they have to cover off, and 2 targets will come out, which could be friendly targets and 1 foe target, or there would be 1 target that comes out, which could be either or. And they would have to work through this game that we created. So the game is based off of time. So they would have to shoot this target as fast as they could and basically they got ranked on a leaderboard, so they knew where each other were, just to create some more anxiety throughout the games. That they now have to compete against everyone else. Though that is not particularly representative, a combat shoot would never stand in the middle of a room as 3 targets come out. The task itself, like, it tends to be embedded in an actual environment. So the task is representative. They would have to identify friend or foe. They would be presented with more than 1 target at a time in a combat environment, especially an urban one. So the task itself is representative. So they helped us make that task and sort of helped guide us in what they would normally do. So we weren't too far from the mark or giving them something too out the way that they've never done before.
Yeah.
That was something that we almost changed on the fly. I think we went up there and we had an idea of what we wanted to do, based on some previous research of pretty much the opposite of the person we were interested in collecting data on actually entering the room and engaging. And they said, no, actually, most of the time what we'll do for a training drill is actually have the person in the room and there'll be people coming in. So that actually changed how we collected the data, and that's because of the great relationship we had with them, to be able to co-design that, which I think was a strength of that data collection for Jack's PhD.
Yeah, I mean, that's a great example of co-design.
Yeah.
And it's not just a bunch of academics coming in and saying, well, we've got these theoretical ideas that we want to test, thank you very much, and we're going to use you as guinea pigs. But this is really great pragmatic skill acquisition research based partly on their needs, and they're informing the design based on their experiences. So we're using experiential knowledge from their lives. And it's also partly based on fundamental questions, theoretical issues that we want to look at, including, for example, the use of technology, Kane, in providing augmented feedback. Martin, you made a great point earlier about when you're practicing shooting and you're not really getting feedback from, how you're doing, sort of thing, and whether you need to change anything. Just be yourself. Nobody, not even an instructor telling you do this, do that, which is like a form of augmented feedback. But the best sort of intrinsic feedback comes from the shooter themselves adapting. And so, yeah, Kane, there are these technologies that are now becoming available that can provide feedback to the shooter, and you're interested in them, aren't you, with this project?
Yeah, particularly the Mantis X that I mentioned before. It's a relatively low cost inertial measurement unit that goes on the barrel of a weapon. It can go on a rifle, it can go on a pistol, it can go on a bow. There's an archery one, it can go on a shotgun. So they cater for a range of sports as well as military. We found that it was reasonably good in detecting movement, which it should. It's an IMU, so it should be able to get angular velocity quite well. We did a small validation study. We're pretty happy with it. Reliability is hard with something like that because humans change and they adapt. So it's hard to differentiate where differences are occurring. So we did get some reliability data on that, but we can't distinguish between what is the sensor error versus just humans shoot differently from one time point to a next. So that's something where we did probably half of that project was related to the Mantis X. We did with Alex Roberts, who's now at the Queensland Academy of Sport. She led some interviews and focus groups with shooting coaches and shooters themselves to understand what the needs are or how acceptable a sensor would be, and they were quite receptive to it. As I mentioned, we did the validation study, but then we also did a training study as well. And unfortunately, due to the reality of working with military personnel, they've got priorities that come above something like a training study. So we went in with getting pre-data from about just shy of 40 participants, and we ended up getting about just over 20 coming back. So in terms of powering the study to distinguish whether the Manchester X had a positive effect on shooting performance, we're not overly confident with the data just from a statistical power perspective. So there's a bit more to do with that. And it's something that can be done with dry fire. So it's a simple way to reduce resource costs for military. We did get some qualitative data from the users as well throughout that process. And one of the big things that came out of that is understanding at what point in a soldier life cycle or training cycle is the most appropriate. So is it recruits? I've got thoughts around reservists. It could be quite useful for them. Or is it more specialized, more experienced shooters? It wasn't quite clear. It wasn't unanimous in terms of who that would be most useful for. On the other end, I think there's a place for VR and augmented reality as well. The design of those are good. The resolution of VR is getting better and better. I think augmented reality is probably a good way to go. I would love, our lab, Keith, you've seen our lab. It's relatively large. I would love to be able to create some kind of augmented reality lab in there for shooting. Unfortunately, we can't have weapons in the lab to be able to do that. So again, that representativeness suffers a bit. But some kind of VR or augmented reality, I think, has a place as well. And some of the technology that's being developed, there are ones that are on the market where it is pretty much designed like a rifle, where you've got a buttstock, you can put it in the shoulder, it gives a vibration, so you get some feedback as well. So I think there's a place for that as that technology matures, and will continue to mature over the next years to decades.
Yeah, that sounds interesting, and I think it's good when you hear about different feedback systems improving, like haptic and proprioceptive feedback through vibration, etc. But also, it's important to have the action component in as well. And so, yeah, I've seen your lab space, and I think you were being very understated there. It's the facilities at Latrobe are unbelievable, Martin. They are incredible sports facilities and research facilities. And so, yeah, a lot of lab space for the action component using VR to be undertaken with appropriate opportunities, affordances for movement involved as well.
Yeah, Kane just made a great point there that I didn't think of before he said it, but I suppose you could really equate this to like working with really novice type, let's say football or soccer players, and then elite level players, playing in a top level Premier League or whatever it might be. And it's just, but it would be the same in military, because you could have young recruits or units or battalions that don't see a lot of combat, and just by nature of their role, so they won't have a lot of opportunities to do this, so they could be termed novice. Whereas you might have a special forces unit that are consistently being deployed on operational tours and whatnot, and then when they're not, there'll be I know special forces units here in the UK, they do live firing in close quarter battle quite a lot in downtime, I suppose. So you're dealing with two very different groups of individuals there in terms of expertise. So yeah, that would definitely have an impact on maybe the training methodologies. So that's another great point. Jack, I don't know if you can go into this yet, but is there any sort of what have you found? Like, where are the findings at? I know Kane's alluded to some insight there. Is there anything that you could share just to give some initial findings?
Yeah.
Yeah.
Yeah, so we've done the time constraint study and the performance of the task ambiguity study. Last is a behavioral study where we'll look at coordination and couple different segments together to understand what leads a movement. But yeah, in terms of the time constraint study, we found that prescribing a time constraint doesn't really elicit much change unless it's a really severe constraint, especially in quite linear static environments. So making a time constraint context specific, which obviously makes a lot of sense, that is sort of the best sort of time constraint that you could implement. Like I mentioned, if that's to the context of like the range that you're shooting, the amount of decision making that you have to embed in training, that's better than pre-prescribing, then you must shoot within 2, 3, or 4 seconds. Yeah, and then with the task ambiguity performance paper, we actually saw quite interestingly that it takes longer where there's more affordances in the environment. This sounds very straightforward, like you'd expect it. If there's more targets, that it takes longer to decide which one to shoot. But it is actually quite profound for this context. There's been some combat modeling with like dyadic and group-based shooting, where they within the models they put in marksmanship accuracy data and also the time to act data. So the time for the first shot, finding that if your first shot is longer, then you have less chance of surviving an engagement. There is a slight trade-off. Obviously, if you go too fast, your accuracy may go downhill because you're not spending the time to match the sort of constraints of that situation. But yeah, the fact that the longer you take, the less the more your survivability goes down, and therefore the more affordances in one's environment, the slower you take. There is a link there between more affordances and less survivability, and therefore there is a need to look at interventions to help increase survivability with these quite ambiguous circumstances.
Yeah, nice. And
that aligns with what Keith mentioned before. Just there's more information, there's more things to look at in the environment to perceive those things. And I think one big area or opportunity for research is exactly what we've been speaking about in terms of perception action coupling, is how can we make even gaze strategies more efficient? How can they pick up the most important information in the environment to distinguish whether it's a friend or foe? And then, so that's very much from a perceptual skill position. And then from a buying the Kane's perspective, that action component of how then can we help them once they've made a decision to act, how can they act most efficiently as well? So I think this is why combat shooting is such a great vehicle for perception action coupling, is that it's not only those two things are highly integrated, but the stakes, there's not many other actions that we have where the stakes are as high in terms of being able to reduce those times.
Yeah, I like that point. I've always liked that point. I remember, Jack, we talked about in your PhD work addressing the environment, so designing practice tasks that allows a combat shooter to approach an environment and engage with a potentially hostile, or it could be a peaceful environment. It depends on the affordances. But in a sort of a way of addressing it, and by that I mean that the way that you orient your body in space, the posture that they adopt, and even the way that they have they handle the gun, the weapon, in terms of being ready to engage with the environment. And that has changed, isn't it? Really, in terms of there's been little attention about the position of the gun. It's always been thought to be there's a universal position, just keep it like this. But in a combat environment where you've got so much more uncertainty, as Kane said, and then you've got all these different affordances, you've got to be ready. And so by addressing the environment in a way that's functional, you can improve your chances of survival.
Yeah, no, absolutely. There's this need for, I think we spoke about it last time, like a need for meta stability, basically, where there is really no right or wrong way to address. There's obviously going to be some wrong ways to address the environment, but you know what I mean. Within a bound, there's going to be no right or wrong ways to address the environment to deal with the ambiguities or the uncertainty of combat environments. And in regards to understanding this in more detail, my last study, like I mentioned, we'll be looking at coordination. So we'll couple basically different segments of the body, the rifle and gaze together to understand what leads a movement. And what I mean by that is, do people quite strongly couple their rifle, torso, and body together and move around the environment in this one sort of complete system? Or do they, for example, move their head first, track the eyes throughout the room, and then just move the gun to the right one? It's never been looked at. And though the first option might sound silly to someone who's new and who might not be quite as confident using a gun, it's the easiest way to sort of control the gun, to always have it in front of you, in view, to move around like that. And part of that study as well, we will look just before the start of each trial, so just before the doors open and the targets come out, to understand, like you say, how have they started the trial addressing the environment, and then how has that progressed throughout the trial.
Very good, yeah.
And based on a post on LinkedIn I saw yesterday from Mark Williams, I think we need to avoid the term scanning, because he made a differentiation between scanning is different to head movement and gaze behavior. So I think coupling is quite interesting. We've got the data from, as Jack mentioned, I think we went down to the pelvis, didn't we? So pelvis, trunk, weapon, head, and gaze, and how they all link together is going to be really interesting.
That'll be interesting with what equipment people are wearing as well. I'm just thinking, if you've got like webbing on, the webbing with it can be quite heavy. Well, say probably 30 pounds, it could be, depending on if you've got like a little rucksack on as well, or whatever the situation. But I think that'll be interesting as well, because that's definitely would change the way you're gonna, try and manipulate the rifle, just because it's so restrictive on the body.
Yeah, we actually accounted for that slightly by allowing participants to wear representative equipment, or as representative as possible, whilst wearing Vicon markers. So they were allowed to wear the T-BAS, which is basically their body armor, which has pouches all over it with the different equipment. So it can have magazines or so forth. That way, there's, I guess, these obstacles that the gun has to get around to mount the gun to shoot properly, the same as they would if they were in actual combat.
Yeah. Fascinating. Lots to do still, Jack.
Yes.
Yeah. Keith, was you going to talk? Sorry, I thought you.
Oh, no, I was just going to say that, yeah, absolutely fascinating. I've been involved with this in this project as a consultant, and it's been an absolute pleasure to be involved with. Very thought-provoking, and as Kane said earlier at the beginning, the project moving towards an ecological dynamics approach is very exciting for me, because there's some it's a dynamic environment. It's full of uncertainty. There's a lot of task ambiguity. There's a lot of information there for people to perceive and act upon. And I love the opportunities to co-design using experiential knowledge of military personnel. So we're not just going in and making assumptions about what we've seen in films, Martin, but you're lucky to have had a bit of background experience being in the military a while ago, so you can kind of imagine all this. But so it's a very good example of an applied science project which can contribute to theory and practice in a very meaningful way. So I've been grateful to be involved with it.
Yeah, brilliant. Yeah, just the last one for me. Yeah, it's really made me think, like, the great thing is it's going to challenge people to think differently, or a big organisation to think differently about how they design these training and learning environments. Because I don't know what it's like now, but previously the military are big on booklets and handbooks or procedures, and they'll have very rigid, like 2.13 page 8, and you're literally learning off this handbook. So why is it like that? I don't really know, but and I think it's a great opportunity to really just get people thinking and challenging thinking about better design experiences, learning experiences.
I think you made a good point earlier on when you talked about a lot of these sort of traditions of teaching, instructing, training come from specific context, and there's still a lot of procedural knowledge involved that people have, like an operational approach, and that's assumed to be good planning. And so if you've got step 1, step 2, step 3, all documented in a manual, but that doesn't take into account how the environment is changing, how, as Jack mentioned before, you don't often get battles between two clearly recognizable friend or foe, people in certain uniforms, etc. Now it's full of ambiguity, task ambiguity and uncertainty. Deliberately, there's a lot of deception, disguise used. And so, yeah, it's about also making sure that training methods and teaching methods, coaching methods for these tasks keep up to date with all those changes to the environment, to the context, rather than just following historical documents. Yeah, good point.
And using technology, like I mentioned, they loved seeing the eye tracking data of them doing a run through. So I think, like you said, Keith, not just using something in a handbook, but actually seeing some visual representation of what's a good performance, what isn't a good performance, getting feedback on their own performance. And something that surprised me in the project, and we haven't really touched on it, was not just redefining or augmenting training for the soldier performing the task, but I think we got some reasonably good information from eye tracking on coaches as well to see what they're looking at. So potentially developing some kind of training or framework for coaches as they're coaching shooting. And that part of the project was led by Derek Panchak, who did a good job looking at our gaze data from the coaches as people were shooting. We saw some differences between the gaze behavior of watching someone shooting with a rifle versus a pistol. There's a lot of things to look at. So I think that aspect as well, not just the shooter, but the shooting coach, and helping develop training for them as well is important.
Yeah, implications for coach education, training education, etc. That's very, very important. I like that a lot, and I love the mix of how we're also using experiential knowledge, the actual participants' insights. Because engaging them is quite important, rather than, like Martin, as you said, imagine a scenario where you're in the training environment and a tap on your shoulder means you move forward. The decision is made for you. You go into combat and you've got to make that decision. There's nobody tapping you on the shoulder or pulling you back, etc. You've got to learn to embrace the uncertainty and to pick up the information that's available, and the affordances that you see for moving forward or staying put in that scenario. And so I think designing training methods that move in that direction, you can see where the next steps can emerge.
Yeah, brilliant.
Yeah, and that works quite well with the like what you said earlier, Martin, about there being this handbook. It's the same in sports, right? If your coach has pre-described what you are going to be doing, then you yourself can't use ambiguity to your advantage. Like there's one way of going about it, and you become very predictable. So I guess it's also trying to develop new tactics that again just emerge instead of this predefined, this is how we will do it on this battlefield, and it's very easy to outsmart someone who's sort of training like that.
Yeah.
Yeah, I suppose it's akin to having a team having a very rigid game plan and playing in a very specific way. It's quite obvious what they're going to do. So yeah, good point.
And that's very much akin to offense in sport. Whereas, how can we? And this isn't even close to being what we've discussed or thought about in Jack's project. But how can you increase task ambiguity for the enemy? How can you disrupt what they're doing? How can you mess with their perception to give you an advantage? I think that's kind of something that we did with some of the drills that were adjacent to Jack's data collection in terms of specific drills that they do. So how can you actually increase that uncertainty, or can you distract the enemy in some way to give you an advantage?
Yeah.
Yeah, it just gives you more options, right? If there's more than one way of doing something, and you've got experience in all these different ways or all these different possibilities, then you can try and implement different solutions to see which work as you sort of going through these like urban environments, for example.
Brilliant. Very good.
Yeah. Fascinating discussion, gents. Really, really interesting. Very, very thought-provoking. So yeah, appreciate your contributions. Great.
It's interesting as well. Just a final point that the concepts and theories and ideas of ecological dynamics are being applied to military contexts and law enforcement contexts as well, Jack, isn't it? In the literature, it's becoming more and more popular, isn't it? And there's some good research in Germany.
Absolutely,
yeah, and other areas as well, which is quite striking. It's quite sort of it's interesting to see how these ideas of ecological dynamics have been picked up by people outside the sport context, because this is where they originated, but they're being applied to performance environments in a lot of different places, including physical therapy, including looking at illnesses, conditions, neurodiversity, for example, the behavior of people with neurodiverse systems in school formal education, but also military operations and law enforcement as well. And it's quite heartening to see that people are making the logical leap in the use of the ideas.
So yeah, good luck with the PhD, Jack. And have you got the Viva date yet, or?
So there's no sort of official like end Viva. We do presentations throughout.
Oh, that's right. It's different. Yeah, sorry.
Yeah. Yeah. Hopefully it won't take me too long to get the last paper going, and I put it all together.
Yeah. Well, all the best with it, and yeah, good luck.
Thank you.
Yeah, to you both. And thanks so much for sharing your expertise and knowledge. Really appreciate it. It's not at an optimal time, I suppose, for you in Melbourne. It's suitable for us here in the UK, but we really appreciate the effort that you've gone through. And that was one of the most fascinating discussions on a podcast. I think that very relevant for so many things. So appreciate it a lot, guys. Thanks.